Audible? You two people? Okay. Sorry. Okay. Start in trouble. Okay. Please bear with me. We will try to have some session. Okay, let us resume. Try to have some business conducted. Last some 20 minutes or so. 16 minutes. Okay. Let us share the screen and say something. Okay, I hope the screen is visible for the YouTube people also. Clearly readable. Those on YouTube, please. The screen shared is okay. Okay, thank you. There will be some lag. That's why you're waiting. Okay. So what we have discussed yesterday was two-way automata, and we have seen one example where how the configuration goes. Now this type of idea we will use later in the maybe in the last semester also about last or fifth semester about Turing machine also. This tape and read head extra and configuration is extra. Anyway, for this model, we will represent the current state of the machine using what is called a configuration. Say configuration is written like this. Okay, if delta PAI, that is okay. For that, suppose the string is on the tape, x is on the tape, that is A1 to AN, and they will be enclosed between the left hand marker and the right hand marker. So left hand marker followed by the string and the right hand marker. That is how the string will be on the tape initially to start with. If you want, you could modify the tape, the contents also in Turing machine extra. Here we won't do that. Anyway, here we will move forward and backward reading and jumping from state to state. Okay. The configuration is normally represented like that. Is suppose you are in P and the next string you are processed is suppose AI, and that is at the position is at I. Okay, that is the read head. I means the read head is pointing to the ith cell. Okay, then suppose you are moving to the Q. State is Q, and you are moving on the left side, so you will reach that means initially you are in this configuration. This is how you represent the configuration. Okay, that is you are in P and you are on the ith cell. On one move, you will if the move is leftward from P, you will move to Q. So the new configuration is the Q in bracket Qi minus 1. You have moved to the new cell like that. If you have the rightward movement is rightward, Initially you are in pi in one transition, that is this one transition on the input string x, you will move to q I plus 1, the forward direction. So actually this will be a new value, I minus 1 will be a new value. So this indicates the position you are. This is the delta transmission, this is the configuration, in which state and in which cell you are. Okay, which state and you are, this is where you are. After one leftward movement you are in a new position, new state and a new cell position, one left cell to the left, this is rightward movement. That is how this is what is called the configuration. Okay, let me check the site. Is any comment from anyone? Okay, okay, okay.
Sir, ഇതിൽ presentation കാണാൻ പറ്റുന്നില്ലല്ലോ ജിറ്റ്സി മീറ്റിൽ.
Wait. Jitsi made people says the presentation is not visible. Okay, try to click on that appropriate my name. Click on my name. Is it visible?
Yes sir, it is just your name.
Screen is not there?
No screen.
Yes sir,
Same
it's
for
visible.
others?
It's visible, sir.
Pardon?
Sir, I can't see. It is
Okay.
written ask. Like,
Yes. The first one, top one. Click on my name, ASK. Because I have used my not the official ID, because official ID I have the YouTube link. Okay, that's why I have used this ID. Okay, I have used a personal ID for this purpose. Now visible?
sir, it is in ask your
Yes.
ASK, but I can't see it.
List the viewers. Sorry, the participants. Must be the first one on top.
Okay, sir.
Others, what is the situation with those in the Jitsi, other students on the Jitsi?
The presentation is visible, sir.
Yes. Meanwhile, roll number 1 is here in Jitsi. Assignment is meant for that. Okay. Your class note assignment is for you. Okay. So who has said that it is not visible? Roll number 13.
No, I'm roll 1.
Okay. Roll number the one who said that screen is not visible.
Yeah, it is me, sir. Roll number 1.
Still not visible?
Yes. No, sir. Can I watch it in YouTube?
Okay. That's you have the choice.
Okay.
You have the choice. I have already stated. Okay. You could join either via YouTube or.
Okay.
Other people, any people on Jitsi have any trouble viewing the screen?
Yes, sir. It's not visible for me too.
Not visible. Look at my name. I am ASK.
Yes,
Click on
sir,
that.
I have checked.
Yes, sir. Yes.
Visible?
No, sir.
Then if you are not able to not visible, you may join via YouTube. No problem. Okay.
Okay, sir.
What about Alan Sam? Could you see?
Hello.
Could you see my screen?
No, sir. It says your logo.
Okay. click ask at the top, somewhere it should be ask for meet is on the top. Okay, must be there. Click on that is what is happening.
Yes, sir, it's fine now. It's being shown.
It's okay, visible.
Yeah, it's visible.
Okay. Those in the Jitsi, please click on my name as ASK. Okay, then the screen should be visible. If not visible, please remind me. Okay. Okay. So let us go on with the discussion. Let me check YouTube. Any messages there? Okay. So what will be the configuration? Okay. So we could define the configuration change inductively. After one configuration, it will move to this is what this one indicates the next position. After more transitions, the definition is could be made inductively. That is, PI configuration changes to PI itself on zero transmission. If PI then on N transmission is suppose moves to QJ, and from QJ there is a single transmission to UK, then you could say PI in N transitions will move to UK. It's very obvious and clear. Okay. Now, if a string is accepted, if after some transitions, if the state is reached, suppose you are starting with S and then the position, initial position is 0, and after some transmissions you reach the state T. Okay, in that whatever be the position you will accept that. So configuration is initially S0, and for some after some time suppose it is Ti, that is state is T and the cell position is anywhere for some I within the limit, that is within 0 to n plus 1. Okay, then you accept it. Similarly, if you start from the starting position, S is the starting position, and current cell at that time cell position is 0, and after some configuration changes you reach the state R, the reject state, then you will reject the given string. That is how it goes. Now for the given case we will illustrate it. We'll explain the same for the example we have discussed. That is the automata which accepts the language where the number of A's is a multiple of 3 and number of B's is a multiple of 2. Okay. Okay. This is the transition table of that two-way automata we have defined. So for example, for that automata, if you give the input, say in this, here it is illustrated, A, B, B, suppose that is the input that we are giving, then how the configuration change happens, let us say. initially it is Q00 to start with. Okay, so that means you are on the left tape. Okay, so immediately while starting the process, here you will move on encountering the left tape. Suppose the machine is commenced, you will move one step right, Q0. On seeing the left and the marker, you will move Q0 one step. So that will be Q0 from 0 one step right means you will move to Q01. That is this configuration. This means initially you are in Q00, you start processing, you are again you are in Q0, but your read head is pointing to the first symbol, that is Q01. From there you will read the first symbol. Okay, that will be, suppose it is ഞാൻ അങ്ങോട്ട് വിളിക്കാം, കുറച്ച് അടിയന്തരമാണ്, ക്ലാസ് എടുക്കുകയാണ്. ഓക്കെ, വിഷയം വിളിക്കാം. ഓക്കെ 1 minute. Okay, so Q0, now you see A, the first symbol is A. As per this on Q0, if you read A, you will move to Q1 and R. Okay, that is why it is Q01. You will move to Q1 and one step right. So one step right means +1 you will move to Q12. That means this means you are in state Q1 and the current read head is positioned at the second position. From Q1 on reading, you will move to Q2. Yes. Second symbol is A. From Q1 on reading A, you will move to Q2, one step right. That is why it is Q23. Okay, and the third symbol is B. Okay, the third symbol is B. So you will be in the same state because you want to consider B and the forward is concerned. So you will be in Q24, but you will move ahead. Okay, then next symbol is A. So at that it is the third A. So you will move to Q0. That is here. From Q2 on reading A, you will move to Q0 more right. That is why from Q2 3 you will move to Q2 4 you will move to Q05. Then one more A. Next is a B, so you will move to Q06. Next is B, you will move to Q07. Next is B, so you will be still in Q0, you will move to Q08. Okay, next it is you will reach the last, there you will move to P07. Okay, on at the end, then you will move backward. That is why you will move to P16, because the backward movement, you from P0 you will move to 16. Then one more left movement, 5 P0. That means 2 P's you read. Then you will move to P14. Okay, then you will move to P13. That is because one you read an A, then you move read backward and you will read this. That is why you will move to P02. Then you will read A, you will move to P01. One more A, you will move to P00. Finally, you will reach T1. Why from P0 on the left hand marker, you see you will move to T and R. Okay, that is the case T. What is that? That is the case of acceptance. That is why because we have seen 3 A's forward, 4 B's backward. Okay, so from P0T, on seeing the left hand marker, you will move to T and it will be in this position. Okay, you have reached T, so you will accept it. Similarly, the other cases. This is how the configuration. This is a simplified method to represent the current position of the machine, any this type of computing machine model. So transition through configurations sometimes will be helpful as to process. In the case of Turing machine that we will discuss later, we will make use of this approach a little more. Okay. Now the second module discussion is over. We'll just very quickly, very interesting topic. We will move on to the third module. We will move on to the third module. There, to start with, we will have pumping lemma. That is to prove that some languages are not regular. Very interesting. Those who have some discrete or mathematical inclination will see it is very interesting. Others also supposed to learn and understand well. Okay, it's up to you. What is called the pumping lemma. Different books present it in slightly different ways. Okay, first we will talk about the pumping lemma and we will apply it, and you will see how it will be very interesting. Normally, pumping lemma is a property which pumping lemma for regular languages is a property which every regular language will possess. That means if a language is regular, that will obey pumping lemma for regular languages. But if a language obeys pumping lemma for regular languages, it doesn't imply that it is a regular language. It's a necessary condition, but not a sufficient condition to conclude a language, a property of the regular language. So if the to prove that a language is not regular, you may use this theorem. Okay, we will go to Powell for that theorem. Okay. Okay, this is it. Pumping lemma for regular languages. So first let us read and then we will explain. Suppose if A is a regular language, okay, then there is a number P. On different books will present it slightly different. Okay, this is from Sipser, one of our references. If A is a regular language, then there is a number P, the pumping length, where if S is any string in A of length at least P, then S may be divided into three pieces. S is equal to X, Y, Z, satisfying the following conditions. 1. For all I greater than or equal to 0, X, Y raised to I, Z belongs to A. Size of I is greater than 0 and size of XY is less than or equal to P. Okay. So repeating once again, suppose A is a regular language, then associated with every language there is a number called P, that we will call it a pumping length. Then suppose take any string in A, any string, it should be satisfied all strings in S. If any string in if S is any string in A of length at least P, okay. So this property is satisfied by any string belonging to a regular language of length at least the pumping length P. Smaller length, this directly won't apply. Okay, this okay. If you take any string of length at least P, then that string should obey this property. That is, what is that? That string S, whichever be that string, it should be applicable to any string from that language. Okay, then that string S of length at least P could be broken into three concatenated pieces X, Y, Z, such that if you pump this Y, this is the pumping piece Y, okay. If you pump this Y, then the string also will be in the same language. That is a pumping lemma property. That is, for I greater than or equal to xy raised to z. So that means x, if you take y as 0, then the resultant is xz. Okay, so xz should be a member, xyz should be a member, xy raised to 2 should be a member. That means xyz is a member, y raised to 3. For our automata theory of computation discussion, this exponent means you are repeating that string that many times. Okay, that is the meaning of it. Bear in mind. Okay, y raised to 3 means y 3 times, concatenated 3 times. Okay, so x, y, z should be in the language. So for all I greater than or equal to c, if whatever times you repeat y, still that resultant string will be a member of the language. Y is not empty. Y is, size of y is greater than 0 means y cannot be empty. But x and z could be empty, no problem. Y, the pumping string portion, string pumping piece should not be, cannot be empty. Okay, and xy is less than or equal to p, and this portion x and y put together should be less than or equal to p, the pumping length. It cannot be more than that. Okay, that is the pumping lemma theorem for. Okay. Okay, we'll quickly stop. Okay, so this is pumping lemma for regular languages. That is, take any string of the language of length at least pumping length p, and then that string could be divided as xyz, and then if you pump y, the resultant string, many times the resultant string will also be in the same language. Okay, we will see examples extra next. Okay, we will stop the process here. Okay, thank you. You may give a feedback on any the experience through the chat, whether was it okay or not. Those listened via initial struggle, forget about that. Initial struggle, forget about that. After it is went live, how was the experience? Okay, those who listened via YouTube and those who listened via Jitsi, please, if you have any comment, if possible, I will address tomorrow, please. Give a feedback, or you could mail back me. Okay. Okay, thank you for listening. Reminding you, give me feedback on why is there any issue which I could address. Those who listened via Jitsi as well as those who listened via YouTube, either now or via email. Okay. Thank you.